My name is Mike Shema. I'm here with my colleague, Vaagn. And we'll talk a little bit about CSRF today, something that many of us probably already know about this poor, confused session writing deputy. And we'll talk a little bit about what the sort of state of the art is around current countermeasures, and then talk about some what we think are better ways of detecting this from a manual perspective, verifying that tokens actually work as they're supposed to be. And then we'll actually come up with a proposal that we think can be much simpler and much more effective than tokens, and explain why those tokens can be bad in the first place. But this is where I break out my old school Cylon impersonation, by your command, where the web browsers are basically doing things behind the scenes in the way that the web is actually designed to work. The idea that the same origin policy only prevents read access to the responses from a cross-origin request, but any resource can make a cross-origin request all the time. So if you're thinking of Jimi Hendrix and all along the Watchtower, the Joker and the Thief always have some kind of way out of here, out of this same origin policy. The point with CSRF is they're trying to find this way out and actually muck about with their victim session context or security context, how they relate to that particular web application. So our theme for today and what we're trying to do in terms of coming up with better analysis and better protection against CSRF was we really want to figure out what's the difference between a user intended action, in other words something that you and I wanted to do, and something that's just going on behind the scenes within the web browser, where that user agent is actually working as a double agent against us, making requests on the attacker's behalf. And again, we want to make sure we come up with a solution that doesn't break the web as it works today. The whole point of HTML is that you can aggregate all this content across origin. So there's no point in trying to unilaterally say cross-origin content is bad. So there's two major parts of that F in CSRF. This stands for not what you're thinking, but forgery. And it has two senses. The idea of creation, in other words, being able to generate that cross-origin request in the first place, and then counterfeiting. So creation can be actually affected by a few things like cross-origin resource sharing that actually makes HTML5 browsers a lot more flexible and web apps a lot more powerful, and as we'll show, it has some very positive implications for CSRF. Then there's the idea of counterfeiting, which is basically where CSRF tokens come from. The idea that we're going to add a nonce, something that's unpredictable, something that has a good random number in it that the attacker can't predict and include in this request. But also too, with counterfeiting we have available to us things like refer headers and the newer origin headers that we can and should be checking that can help raise the bar in terms of countermeasures. But basically all these current countermeasures, the CSRF nonces, tokens, random number generators seeded by the current date or process IDs, what they're really trying to do is just making it harder to predict, harder to counterfeit this particular request. But part of the problem is they're just making the guessing more difficult rather than having the web application make a separation, a good distinction between what is an authentication, in other words who you are, and authorization, what you should be allowed to be doing within the context of this particular session. And that's where they're trying to tie your session, your authenticated current interaction with the website along to that particular cookie. And so that's why they do things like double submitting the cookie, so that if you can predict the cookie in the first place, you can just impersonate the user right off the bat. It doesn't matter. So with the idea of secrets and entropy, these show up in all types of situations, including cryptography, authentication, password hashing, things like that. And the big deal is not really what type of hash function you're choosing, whether it's MD5 or it's HMAC MD5 or it's HMAC SHA-256 or SHA-512. What really boils down to is if you're using an HMAC, you should be using a strong secret. I went out and did a very simple survey of how many websites that I could easily find using Node.js express.connect as their session management. And it relies on an HMAC SHA-256 by default. And by default, the secret for it is keyboard cat. And there were, I found about 6,000 instances of websites using this cookie, and 400 of them at least fell prey to either that default secret of keyboard cat, or they had a nice, very easy dictionary word that was for their secret. Remember, like 1, 1, 2, 3, and at least there were some Tolkien fans in there. But the point remains that if you're going to use an HMAC and you're not using a secret, then you're kind of failing in the first place anyway. Then, of course, there's the idea of secrets being stuffed into GitHub. So if you look back to December and January, there were some announcements demonstrating how people were checking in their SSL or their SSH private keys, as well as they were checking in their Ruby on Rails secrets for HMACs. But you can spend an afternoon, and an evening actually, just searching through GitHub, looking for all the secrets associated with things like OAuth consumer secret, or your session secret, MongoDB admin URLs, SSH connection URLs with the passwords in them, as well as all those secrets for those aforementioned HMACs, 256, SHA-512s, and so on. And so it's the idea that if we're going to try and recommend nonces as a valid protection, we also have to make sure we're not setting up developers to make mistakes or shoot themselves in the foot and accidentally start checking all these secrets into things like Git. Then, of course, there are things like random number generators. They're always being seeded by simple things like the current date or the process ID. Last year at BlackHat, there was a good presentation called Pwning Random Number Generators that was specific to PHP. And essentially it points out that if you were to use something as specific as a mod unique ID and any other random ID within PHP, you're setting yourself up for failure, because mod unique ID actually exposes the current process ID and a timestamp. So it creates a unique ID, but doesn't create a very secret one. And if you're relying on a process ID or a timestamp for your session, for your as your seed, then you're going to fail. I made a note here about sjcl.random. If you're trying to do crypto inside of JavaScript, you're probably making a fundamental mistake already. If you're trying to do random numbers in JavaScript, maybe you're a little bit better off. But fundamentally the problem is that JavaScript is not a trusted execution environment. I think we all know this, but we have efforts like CryptoCat that started off as just a pure JavaScript encryption technique for chat that was basically trying to re-implement TLS with JavaScript, which is the wrong way to go about things. So what I've mentioned here is the Stanford JavaScript crypto library. It's at least a very good reference implementation for generating random numbers. And the reason I pick it out as a good reference is because it relies on some standards for implementing the random number generation, and it includes things like entropy estimation, so that it knows, and reseeding, so that it knows how to keep up a particular entropy pool as it creates these random numbers. And then fundamentally, if you're writing PHP, Ruby, Perl, Python, whatever your language of choice, really if you need a random number, fall back to something like OpenSSL. OpenSSL exists on pretty much any distribution you can think of, and it has a very nice OpenSSL rand bytes that you can either run from the command line like that, or just call its API. And there you're much more likely to have a cryptographically secure random number generator. So don't even bother with all of these other things like the RANDs, or even like Mersenne Twister. If you're thinking that Mersenne Twister has a nice 2 to the 19,000 whatever period, that's pretty good, but it still has a state. And if that state gets exposed and compromised, an attacker can basically replay and reuse that. So again, not cryptographically secure. But then the other thing about CSRF tokens that we've seen is that you can have CSRF tokens and they've been applied to your web application. They're protecting you. But in some cases, what CSRF tokens are really acting as are sort of a duct tape that's on top of an already bad design. And some of these bad designs are something as simple as not caring about the difference between post and get, if that matters for your web application. Or in the last 6 months, you can go to ExploitDB, find a whole lot of CSRF vulnerabilities that have been publicly reported, many of which against embedded devices such as home DSL routers or cable routers, wireless access points. And many of them are vulnerable to things like password change mechanisms, where all you have to do to change your password is supply the new password and verify the new password. In other words, you don't need to know the old password. So that's the idea of a design problem. Another design problem, or a way to handle this, is if you look at something like Amazon.com. if you go and you ship anything to an address that's already been shipped to, then no problem. You don't have to re-authenticate. It's going to pick up your session as it was before, and it's off. However, if you try to ship to a new address, it's going to throw a barrier in there and say you must re-authenticate. And that's a pretty good way that you can make sure that you're still dealing with the identity of the person who you hope you are dealing with, and it's not a barrier that's overly intrusive, meaning that shipping to new addresses are only going to occur a few times. It's not going to occur every single time probably that you're checking out. And really what it boils down to, the CSRF problem, is that we've loosely coupled identity, what you can do, and what your current session is. So a few more rants about the current state, and then we'll get into some more details and some more technical items. So bear with me a little bit longer. Mobile apps. These are really interesting. We were going to take a look at some mobile apps, but to one degree they're just recreating vulnerabilities from first principles. We can go back and look at all these mobile apps that haven't even bothered to use HTTPS for connections. Therefore we can start sniffing them. Then the ones that started to use HTTPS weren't even bothering to verify the certificate. So therefore why even bother to have HTTPS in the first place if it's not even going to throw up a problem with intermediation attacks. Plus, what we think that there will be some interesting things to start looking at is mobile apps that are just making HTTP requests and they don't really act like browsers, but perhaps they have a session context and related to some social media. For example, Facebook Lights or Twitter or any other social media like that, and how could they possibly be abused? Anything like malevolent ad banners. Ad banners are a nice recurring theme of BlackHat conferences. This year there was a good demonstration of malicious ad banners. Last couple of years there's been other demonstrations of what bad things ad banners can do in terms of serving malware. And of course, if we're talking about CSRF, or we're talking about clickjacking, or we're talking about other types of browser attacks, take your phone or take a browser, and then, this is the dirty Callahan postulate. How safe do you feel, how lucky do you feel, punk, clicking on this QR code? You don't even know what that URL looks like. So, we're going to get Vaagn involved here in a second. Talking about what our new tool is that we want to share with the community that moves beyond just basically a very passive, static-based approach to testing CSRF, sort of security by regex. In other words, is there a CSRF token there? And if it's there, good, and if it's not there, bad. What we really want to do is switch that type of testing and that verification of whether those CSRF nonces actually work into an active test that relies on actually a browser that's actually building the DOM, interpreting JavaScript, and going through the process of actually replaying an attack rather than just guessing whether an attack could work. So Vaagn, why don't you talk for a bit?
So we have a browser called Berunda. It's a double-headed bird, Berunda is, and the browser is also double-headed. What it does, it lets you browse the same site on main browser and the test browser. Each one of them keeps its own accounting. Everything is local for each browser. But one thing that happens if you want to, while testing CSRF on forms, you could make test browser submit cookies from the main browser. So for example, this failed because there was a CSRF protection mechanism in place, and test browser with swapped cookie jar, basically cookies from the main browser couldn't submit the form because backend was checking to see if CSRF token attached to that cookies, to the set of authentication cookies is valid or not. And because there was no validity, it failed. The regular case with browser working with its own cookies would look like this. It would go through. So this was a case where there is a CSRF protection, and clearly this shows the failure. And and it's done on demand, basically by clicking onto this button that just swaps the cookies for a second. Not for a second, for a request. So let's demonstrate a protected application. And on this one, just a second. So what's going to happen now, if we submit in a main browser, it's successful. If we do the same thing on a test browser with cookies from the main browser, it succeeds too, because the token verification mechanism was flooded. There was some problem with it. Okay, that's it on the demo. Back to Mike.
So what to reiterate what was going on behind the scenes there is that the tool is basically checking, is your cookie actually associated with the browsing context of the current browser. And the browsing context means that web page that's built with the current set of CSRF tokens. So the idea of swapping tokens is that your cookie obviously is going to identify you, but the CSRF tokens should identify you or should authorize you for that particular browsing context. So that's why if you were to come up with a new equivalent cookie, but use them for different tokens that are associated with a different authenticated session, the interaction should fail. And so that's what we're going on, that's what we're trying to convey there, and we're trying to help to offer out as a tool to make that type of testing easier. So we'll take a switch now and move off of just kind of that analysis of the problems and detection and talk about some better ways of providing protection. So CORS, cross-origin resource sharing, is a pretty awesome aspect of HTML5. It came out of the fact that, as I mentioned, the web today is built with all types of commingled resources within a web page, and developers wanted to be able to, in some cases, read the responses and deal with content cross-origin. But they were coming up with horribly insecure things like JSON-P, which is basically, here's an eval running code that I'm taking from another origin. So really bad things can happen with that. On the other hand, CORS says here's a way to share content, but an outcome of that is also that if you have a non-simple request, and in this case a non-simple request means you've added a custom header, something like x-CSRF, or you're using a custom verb or something like x-CSRF, then the browser is going to make a pre-flight request. And that pre-flight request is really important because it's basically saying from one origin going to the destination origin, am I allowed to send this? And if you were to basically broker all of your requests on your site through an XHR request that included a custom x-CSRF header, you've effectively blocked CSRF attacks against any of those requests that go through that XHR request. Because in the sense of forgery of creation, an attacker who's on a separate origin can no longer create and inject that particular header as long as the victim's using an HTML5 web browser. So that is unfortunately the little caveat here, the little asterisk in the fine print that says your users have to be using an HTML5 enabled browser. So, so with CORS, as I said, it's going to, the drawbacks is that it only works for non-simple requests, and it only works for HTML5 browsers. Plus you have to build this design in from the beginning of your app. It's sort of like if you're going to go back and retrofit CSRF nonces, you might as well also consider retrofitting something like these. The drawback though of this type of XHR brokering is that you need to still be able to have people land in your web application. So if you're listed on a Google or a Yahoo or Bing search pages, people need to land onto your index.php with a simple get. So it's the idea that that get page, obviously you don't want to have any activity on there that would be CSRF attackable anyway, but you couldn't do everything through this non-simple XHR because of this sort of landing consideration. Also make an aside. Every time we talk about CSRF, there's always objections that come up in terms of, well, what about HTML injection? What about cross-site scripting? What about sniffing? What about SSL downgrades? So these are all effective, legitimate attacks, but they're sort of orthogonal to the problem at hand. If we're going to talk about cross-site scripting, there's an attack that's executing within the same origin anyway. And we're trying to talk about cross-origin requests and try to prevent and control cross-origin requests. So we're sort of setting aside XSS for now and saying either stop using the string concatenation and start using things like content security policy to help block and mitigate XSS attacks. And things like man-in-the-middle attacks, DNS attacks, cache poisoning, sniffing, we really should be using HSTS. However, other than PayPal, I'm not sure how many popular sites out of the Alexis top 10 are actually using HSTS, even though it's proven to work, is proven to be rather effective. And we've talked about DNSSEC for quite a long time, but once again, that doesn't really exist quite yet in a nice, well-deployed manner. So one of the other things, talking about needing HTML5 browsers, we at Qualys run a tool called Browser Check. And this is basically, here's some data that I've graphed from this, which is about 20 months of data where we've increased the total number of targets that we've scanned. So basically the graph on your left shows our sample size has increased. But even as that sample size increases, the number of insecure browsers that visit this website that have an insecure Flash or an insecure Java is pretty much flatlined at about 1/5 of them. So 20% of you in this room potentially has an insecure Flash or Java on their browser. Now of course this is a little more sophisticated audience, so hopefully it's a little bit lower. But I for one have them uninstalled because the only dead languages I'm interested in are things like Latin or something like that, not the Flash or Java. And I will admit to having Silverlight installed because I like watching old episodes of Battlestar Galactica on Netflix. But I mentioned once again talking about HTML5. How do we have secure browsers and things like cores and content security policy? There are still ways we can abuse, as hackers, abuse things like CSP. So here's a trick that we could actually generate a CSRF request. So this web page is the page that I've set up on my own site. And what I've created is just using a meta tag here for simplicity, but I've set a policy that says no images can have a source attribute. And yet I've gone and created a source attribute for this image. Therefore I violated a policy. And since this is a policy violation, I'm going to report it to my report URI. And the report URI is where I'm going to inject, or that's where I'm going to craft my CSRF attack. What's really cool about this is that we get a post out of it. So there's really, the only other ways of getting a post are using the XHR object. Otherwise, if you're using images or script sources or iframe sources, those are always going to generate GET requests. So we can generate a post. The only drawback is there is an origin header here that's set to null, which is a good thing. That's what the spec has said we should be doing. And we cannot control effectively the post data. So the spec has also been pretty smart saying that everything that shows them the document URL or that violated directive should be percent encoded. So we can't be really tricky or wily and drop in an ampersand and add a bunch of new name value pairs. We can, however, get a post verb and get a URL with some URL parameters that are completely of our creation, but I just sort of mentioned this kind of as a trivia about perhaps things that you wouldn't have thought of in terms of abusing the CSP's report URI capability. So, if anyone here, if CQDX means anything to anyone here, then you probably already recognize SOS. So, SOS in Morse code was basically chosen because it's very simple to send and it's very simple to understand. Dit dit dit, da da da, dit dit dit. Probably everybody's come across that, everybody's heard of that. And SOS is sort of what we are, that kind of mentality is what we've adopted in terms of our proposal for fixing CSRF perhaps once and for all, or for at least a good amount of it. So, talking about a new spec, a new proposal that we would say is this is a way to actually block CSRF if we can get the browsers involved. And what we're trying to do is focus on that concept that attackers are abusing the session. In other words, they're abusing cookies because cookies today are, for as broken as they are, they're basically what represents the session within web applications. And what we want to do is control when those cookies are going to be with accompany a cross-origin request. We don't want to break those cross-origin requests because we want to still be able to allow all those lolcat pictures and everything else to load in forums and whatnot. We just want to isolate that user session context to the actual application where they belong. So we have a syntax that looks pretty much exactly like content security policy, and we're adopting that pre-flight behavior from cross-origin resource sharing. So the benefits of this that we think is that you can actually apply this now, you can backport this to current web applications just using some WAF rules. So you can just throw some headers on there and you don't need to be modifying any JavaScript frameworks, you don't need to be tying some JavaScript frameworks onto your app, nor do you need to rely on your WAF to do any inline rewriting of content, adding on the fly tokens to forums and so on. So the other thing is we're trying to design this as we were thinking it through is that of course we want it to succeed, and there's a lot of different things and different scenarios and different concerns that people have building web applications. We could probably have an really interesting discussion on the do not track header and how successful it is and whether it should be on by default, not on by default. You know, if we're a security community and we come across security settings that we want to be on by default, we're trying to help our end users. But if we come across privacy settings that we think improve privacy, there's then a little bit more contention and a little more conflict in what should be your default stance on privacy versus what shouldn't be. And the biggest point here though is that, you know, our proposal, if you're going to pick out any major flaw, it means that browsers have to support it. So we're looking for feedback today from people who develop websites, people who hack websites, people who build web browsers. You know, how much of these ideas do we think can work? And we'll try and take those, update a spec, and share something that hopefully can be accepted and implemented. And as I mentioned on that slide, the chart with the 20% of browsers still being vulnerable to Flash and Java, is that old browsers have probably more substantial issues anyway. If you're worried about CSRF because your visitors are using IE6, you should also be worried that your visitors are using IE6 and they're going to be vulnerable to malware, a lot of other attacks, and things like Aurora attacks. So if we're trying to look in this grand scheme of things and the idea of risk mitigation, we should keep that in mind as well and just try to move people to be using the latest browsers anyway. So this is what it looks like. We would have, for example, anytime you would have a set cookie header, you drop a content security policy header in there and you say SOS apply. And you say you want it to apply to this cookie or this couple of cookies, or you want to apply it to all the cookies. And then the directives are simple. We've got 3 of them: self, any, or isolate. So these policies mean, basically they say self and any are how you can set up an exception-based policy for your website. So if you have a policy of self for a particular cookie, like your PHP session ID, when your browser comes and is about to do a cross-origin request, it's going to make a pre-flight check. Otherwise, if it's coming from the same origin, it's going to work the way it works today. Same thing if you have a policy of any on that cookie name. It's going to also trigger a pre-flight request if this request is going to be cross-origin, and then unless there's an exception given, it's going to include that cookie for the cross-origin request. Or if you're something like a bank, or you just don't want to play well with others, or you don't like playing well with others, you're going to use an isolate policy, and that basically tells your browser, anytime there's a cross-origin request that comes into me as a destination origin, just don't bother including that cookie. Only include that cookie when the request is originating from an origin that matches that cookie. And basically isolate is sort of a way to say we don't even want to bother with pre-flight or have any concerns about the potential overhead of what a pre-flight might imply. So to sort of walk through that again, if there's no policy on the cookie, or the cookie has a policy that does have a policy and the request is coming from the same origin, the web just works like the web today. Your browser does what it's expected to do. And as I mentioned, if the policy is isolated, then the cookie is never going to be included on a cross-origin request. So we're not interfering with the forgery concept, the creation or the counterfeiting of the request. You can go ahead and do that if you want as the attacker, but you're not going to get that session cookie to associate with it. So the browser is going to prevent the victim from accidentally either visiting this page or clicking on something and sending their cookie along with that request. Then if we have that policy of any or self, that's where that pre-flight concept comes in. And we threw the pre-flight in there so that we can actually have a default policy for your entire website. So your entire website's a blog. We have a policy of something like any. We just want to say, by default, we think it's okay for these cookies to come in and be associated with cross-origin requests, except for a particular directory. Maybe there's a particular resource we want to make an exception for, something like a /admin directory. You don't want visits coming into the /admin directory cross-origin. That probably doesn't make sense from the perspective of your architecture design. So what you could do is basically say we have a default policy for our website, and then per resource, per directory, or per page, you can actually make these pre-flight request responses so that you can actually have more granular control now with your website. And this is sort of a way that we think possibly makes that cookie a little bit more flexible, because cookies are limited by domain and a path attribute that's really not useful and isn't a security barrier. But in this case, you would have something that looks like a CORS request. It says access control SOS. In other words, this browser is about to make a request that's cross-origin, and it's going to, for this destination that it's going to include 2 different cookies. So it's basically saying, I have a default policy for these cookies. Is there an exception that I should apply to this? And the server either says, yeah, there's an exception. In fact, normally you are not going to include those cookies, but I'm going to allow you in this instance. So SOS reply allow. Or normally you are going to include this cookie with a request, but you know what? This is an admin directory, or this is a transfer, this is a transfer bank account directory, or an action or a specific URL that handles financial information. Therefore, I want to deny you from the browser from including that. And of course, we also think that we'll throw on an expiration in there so that if you're worried about the overhead of making requests, we can say, hey, browser, you should cache this response for n number of seconds. So check again later. So the idea, to help kind of reinforce what we're talking about here, is that if you had a default policy of any, your cookie is going to come across origin request. Basically, it's going to act like the web acts today, unless you get an exception in this response. If your policy is self, then the browser is going to say, I'm not going to include this cookie unless that particular resource says, yeah, go ahead, send along this cookie from that cross origin. So we think that this can be, you can be more helpful now with, on a per resource basis, apply this protection. So rather than having to audit all of your application, look for all the forms that have to be applied with CSRF tokens, you could look for all the forms and apply headers to them. And probably you can do this a little bit more easily with a WAF that has something like just some regexes, or you do some mod rewrite tricks, things like that that are helping to protect this. Also, it doesn't involve any nonces. You don't have to know anything whatsoever about crypto. You don't have to know anything whatsoever about seeding those random number generators. So hopefully there's fewer mistakes then that developers can make trying to implement and adopt this. So there's 2 major categories of things that are being tracked here. The policy is being applied to a cookie, and the browser is tracking how this policy and the destination origin, the resources on this destination origin. We also think there's some tricks in there that this pre-flight response shouldn't leak any additional information about the web application. In other words, you shouldn't be able to just use a pre-flight response or requests to be able to enumerate what all of the cookies are for a web application. Or perhaps this would be another way yet to enumerate hidden directories, or figure out what are the special directories and what are the unprotected directories. So kind of put that in there as an afterthought in terms of being able to once again abuse a browser or abuse new types of policies. I think we've got a demo. We'll actually show this in a second. So to reiterate, let me skip that. I think I've said that much. So we'll have Vaagn come back and show, basically what this looks like in action. But we think that this idea of this SOS policy is that it has a very familiar syntax, especially if you're already trying to deploy CSP and cores on your web application. Has a very small command set, so it's really hard to get too much overlapping and confusing logic. And we do, however, acknowledge that the idea of pre-flight might be anathema to people who are worried about minimizing latency as much as possible. That's why we threw the expires header in there. And the other thing is that we're only tracking all other origins to your origin that you're protecting. We're not trying to say this particular origin can include cookies, but this particular origin shouldn't include cookies. We only care about the destination. Netcraft, I think, is tracking around 1 billion web applications in 2013. So there's no point in trying to create some map of 10 billion to 1 and try to figure out which ones are allowed to include cookies, which ones aren't. So Vaagn, why don't we show what this would look like in a browser?
So right here we have a very simple browser that is based on a Qt demo browser that implements SOS support. For the sake of a demo, we have a couple of local sites set up. The main site is my site that has SOS policies set up. It has remember Mike says there is any, isolate and deny. This has any set up, so all the incoming, so basically all the links on this side can be accessed with the cookies pushed to them from anywhere, unless there is an exception. And for this side there is an exception, which is admin/delete me, which we try to isolate from the rest of the world. So if somebody wants to come to delete me from random evil site and social engineers you to click here to win an iPad, which was supposed to go to my site, admin delete me, and assuming that I'm already authenticated with my site, it is gonna do some distraction. And what is gonna happen now, the delete me won't work because the cookies won't be transferred. Sorry? Yes, but you can't really social engineer a person to also refresh it again. I mean,
there's only so many patches for idiocy. That's the only point.
We're just trying to make the old stuff work. Like, for example, search results have our website here, and when we navigate from the search results to my site, it is authenticated. The cookies are transferred. And locally now, if I do delete me, whatever it was deleting got deleted. So it worked, as well as it put with refresh, but that's a separate story. And without refresh, even without having that refresh disabled or somehow protected from that refresh, you still can have a protection from probably 95% of all the CSRFs that are done even without user acting in any way, clicking or refreshing or doing stuff like that. I think I'm done. Back to Mike.
Okay. So I realized that, the slides that we were going through that's where it was really going on behind the scenes. We're showing you the headers where you're seeing in the browser that you are protected, And one of the points is that the user doesn't have to know what's going on behind the scenes. We could propose things like browsers should support isolated tabs so that you can have this tab has its own browsing context, its own cookie context that doesn't leak into any other tabs. That would be pretty cool and pretty effective, but probably the audience here is going to do that or even use separate browsers, one for banking, one for email, et cetera, et cetera. But we shouldn't place that burden or expect that burden to go on to grandma and grandpa or unsophisticated users. We're trying to help the entire web and help people who don't really have to care about what security is, but we're trying to be good citizens, if you will. And one of the things that I wanted to reiterate is that one of the ideas behind this approach is the WordPress problem. So WordPress, very excellent software. I use WordPress.com myself with blogging. I love it, and it has a CSRF, anti-CSRF token built into it. So the developers are pretty smart. The HMAC is also pretty solid. It's a very nice long secret that they use for it, as well as the WordPress generates its own secret. The developer has their secret, and for its nonce, it uses the two of them together. However, you can look for over the last couple of months of 2013, there's been several CSRF vulnerabilities reported for several different WordPress plugins. And the problem is you have a defense, you have a countermeasure, but developers have to make sure they continue to use that countermeasure. So the fundamental theme for all of these WordPress vulnerabilities or disclosures was that the plugin needs to use a CSRF token. Plugin needs to use the CSRF token, et cetera, et cetera. In this case, with something like the SOS apply approach, what you could say is that you want your blog, your website to work like it does today. So you could, for example, set a policy of SOS any for all of your other cookies, but perhaps set a policy of SOS self on the session ID. Or even you could even have a exception that it gets applied so that anytime anyone visits the wp-admin directory or the admin.php page, bam, you throw an exception on there so that pre-flight response to the browser says, hey, you are not supposed to include a cookie, therefore this plugin that still was technically CSRF vulnerable still can't be exploited because that browser isn't going to include that cookie. And this is what we mean by being able to use that WAF and be able to retrofit these headers so that you don't have to worry about trying to go back and fix the code or relying on very disparate set of developers. Some people that are very good, very 10 years of experience. Other developers who've just read PHP in 24 hours and they've decided that they'd like to create a really cool WordPress plugin. So social engineering did come up. This perhaps could help with mitigating social engineering. Of course, people are very creative or very stupid. Take your pick. And so we can't solve all the things, but we could also recommend that something like SOS headers can hopefully fall into that category of the X-frame options headers, where basically we should never really see clickjacking attacks anymore, except for older browsers or websites that haven't done X-frame options. They haven't applied that header very effectively. So to summarize our approach, we didn't rely on secrets, we didn't rely on entropy. We're just relying on some very simple headers. We think this should be, for example, easier on embedded devices. Embedded devices like your cable modems and DSL modems that are probably all vulnerable to CSRF right now. Also, there's fewer mistakes that developers can make. They won't be checking any secrets into GitHub, or at least they won't be checking these secrets into GitHub because there are no secrets to check in. They won't be seeding the random number generator with the current time of day or with the current process ID because there's no random number generator to seed. They just have to make sure they can figure out what a policy is between self, any, and isolate. And then there's exceptions for allow and deny. So hopefully that's a little bit easier. We think this exception-based approach still gives you flexibility. So cookies are applied site-wide, origin-wide. This policy is applied origin-wide, but you can also take advantage of pre-flight and make exceptions. So one area of your website can be more secure or more protected than another area. And of course, if you just don't want to play with anybody else and you say browsers don't send me cookies unless you're coming from the same origin, from my origin, you just isolate it right there. So that's sort of think about your banking environment. So There are two, of course, major problems that we have to go over here with. One is that we need to update the browsers not only so we get more secure browsers, but we need to make sure that they can have support for something like this, or they have support for core, so you can take care of those x-CSRF custom headers, for example. And there's good reasons that I think the only good reason that I know of for people to use older browsers is if you're encouraging them to use like the Tor browser. And that uses Firefox's ESR release, which keeps up with security patches, but is older, but is very good for people that want to use Tor. Otherwise, if you're using older browsers, make yourself secure, download something new. And of course, if you are trying to fix those old browsers, you're still really going to have to rely on those CSRF tokens. So CSRF tokens aren't going to go away. And as I mentioned before, the adoption of HSTS has not been across the board, and DNSSEC has not become ubiquitous. So just because we have solutions doesn't mean people use those solutions. And that's one of the reasons that every year BlackHat DEF CON still get to show off 0 days and still get to show off new vulnerabilities against old software and new software. So if we were to leave you with some final comments, it would be start using HSTS. It's just better for many other reasons than CSRF, but it has some incidental benefits as well. Start using cores. Consider using that, because if we are going to get SOS convince some browser developers to implement this and websites to actually think this would be useful, we of course need somebody to help us along. So we thank you for your time. Come tomorrow to listen to Vaagn and a colleague of his talk about another HTTP denial of service sort of analysis tool. And we hope you have a good BlackHat. Thank you.